recently by some mapping error problems that have been sent to us by by our clients. So in most cases, this would affect almost all of you or any of you at, any one of you at any particular time, where the client reports a call that didn't plot or map, or like we have in Newton all the time, these CAD issues, okay? And knowing a little bit more about how calls, what's supposed to happen when a 911 call comes in and when the mapping software or the CAD mapping tries to plot that call. So I just kind of wanted to just go into a few basics. Most of you have heard this before. Some of you already know this. I know Curtis has a bigger background in telephony than the rest of us do. But it's all traditional, not next generation based, because that's what we have in this world now. Everybody's moving into next generation, but very few have actually legitimately implemented true next generation call routing. It's out there in pieces and bits, but not 100% as conceived yet. So hold on, I'm going to close my door since my son's reading to my. Okay. And I just pulled up some PowerPoint blank that's pretty ugly, and just go with me. I did this morning because I'm like, I just don't want to talk without having you guys having something you can look at while you try to drown me out in your thoughts with all the work you have to be doing. Okay, so and start with just.
You really captured my thoughts about this.
I know, Ryan. Mute yourself and listen, and we're going to try to keep this at about a half an hour. Okay. So the reason we want to have this, and we want you to have this information, is because resolving reported mapping errors might rely on you knowing something about this. So the things that you would have to know are like the type of device that placed the call. Was it a cell phone, a landline phone? Was somebody texting? A wireless call, a text message. We'll talk about these in the next slide. What traditional landline, VoIP, or I think I got them. Okay. So also the class of service that was reported. So when you use a wireless phone to call 911, it can come into the 911 center as phase 1 or phase 2. We'll talk about that, but those are classes of service. A class of service is basically a 4-digit abbreviation. For example, landline calls are divided into residential and business. Those are two different classes of services. And a lot of software, including our own GoToIt software, uses that class of service to determine how to map the call. Hey, it's a wireless phase 2 call. I'm not going to map the tower address. I'm going to map the coordinates because that's more accurate. Okay. And then finally, how that call mapping software handles each class of service. Now, that being said, you may not know this. I don't know this for a lot of our clients, and I make a point of asking. And we'll talk about how that can branch off in just a minute. But those are the 3 things, okay? When Julie came to me and said they're having this issue, was it in Marshall County with the VoIP call, Julie? I can't remember where it is. Yeah. My first question back was this a VoIP call? This was a VoIP call because it was basically going to a routing center in Colorado or somewhere and not ever going back to the 911 center correctly. Okay, when I heard that word routing center, I knew it was VoIP. Talk a little bit about that too. VoIP, by the way, voice over IP. Y'all know what that is, right?
Yes.
You're using a landline device, but it's not connected to the landline telephony network. It is a IP-based call. Okay. Okay. So, different ways you can call 911, landline phones, cell phones, VoIP phones, landlines in private exchanges where you have to dial a 9 or some other code to get out of that exchange, but to dial people within the exchange or just dialing a couple, digits. Our Grasshopper phones are not a private exchange, but they're a digital version of that. Okay. Does that make sense? You know, like if I'm sure if any of you worked at a large company in the past, you had a telephone on, well, maybe none of you are old enough. I am. Telephone on your desk, and you could just 2 and hit, the person, your whatever, yeah. But if you want it out, you hit 9 plus the 10-digit number probably, or at least a 7-digit number. So text messaging is now being connected to 911 networks. I've only got one client with GoToIt that those calls are actually coming through with a coordinate to map. Okay, not the best way. If you have other ways of calling 911, picking up a phone and using text is not the best way to do it. Again, it probably will get better with next generation 911, but right now what they get is a pop-up on their screen, and if it's connected to the 911 network, you get a coordinate location that's popped in, but that's the only thing you get. You don't even get a callback number. You just get that text, and then the dispatcher can actually text it back. That's basically how it works. Okay. So these are some examples of those 4-digit classes of service. Private exchanges have a lot of them. There are lots and lots of different CTNX and things like that they can use for class of service. Landline phone, the traditional ones are residential and business. Cell phones, a phase 1 call, it hasn't interpreted the location of the caller. It only knows what cell tower it came from. So it's going to give you that address for that cell tower and the coordinates for that cell tower. That's the WRLS and WPH1. Different carriers or different systems use different combinations of that. WPH2 is a phase 2 call where the system has interpolated the location of the caller. And there are 2 ways of doing that. One is by the handset solution. It's the actual coordinate of the caller of that phone. And the second one is the triangulation or trilateration. It's basically calculating that position based on hopefully three tower locations. It prorates distance and time and does a whole bunch of math and decides where you are. Okay. VoIP uses VOIP. Text messages using text. And like I said, the private exchanges are varied. So, if you have an issue and somebody says the call didn't map as it was supposed to, you need to know how was that call placed. And they can go back in their call taking and tell you what their class of service is. A lot of times these just get escalated right up to me, but I think it's important that all of us understand what's going on. A 911 cell call does not.
In a lot of cases, in my experience, the client has a different expectation about the way that it should,
Yes.
the way that a point should geolocate based on their limited understanding of the way that the CAD works. Get into
we
this
do
with Chancey all the time.
And you're 100% right. And they have a complicated CAD that's built on algorithms that I now understand that I didn't before. Basically, it's taking all that spatial data, converting it into SQL tables and running queries. So it's making spatial queries in a table, but it's relying on imperfect data, an imperfect world. So anyway, so we do a lot of educating back, or I do anyway, to make people understand. I mean, often they come to us as their first point of contact instead of going to the cell phone carriers, because all their calls are coming in as phase 1 calls and nothing is actually coming in as phase 2. That's a network error usually with the cell phone company. But what we can do is pinpoint, is it all the carriers? Is it a specific tower? Is it just your T-Mobile calls? And we can go back through our call logs if it's our GoToIt clients and find out when this started, when the last phase 2 call came through, and we can kind of point them in the right direction. And is it our responsibility to do that? No. Is it what makes our company stand out among our competitors? One of the things, yes, is that we'll go that extra mile because we understand more than just GIS and addressing. We understand how all the components are used in 911. So, okay, questions to point. Ryan brought up a good one. with the client's limited understanding of their software is a big issue.
Well, in Chancey's, case, I think that she has, they're relying upon certain tools like, the cross streets feature, which isn't going to work. It's not going to give you the expected results if the line is segmented between the two intersections.
Right.
So I had to explain
we had that come up. Yeah. Yeah. So an intersection, if it wants cross streets, but the only cross street is itself because we have two, a center line representing a city block, but that city block is 2 blocks long. So we cut it in the middle to the 100 block and the 200 block. It's not a true intersection. And so if it queries that point, there's no intersecting roads to return, basically. Yeah. So there are a lot of things that can happen just because of the GIS, how GIS works.
That particular thing is usually a CAD, not all CADs have a problem with that, is what I want to say.
No, you're exactly right.
Some will figure out the intersections, and they do it right, no matter how much segmenting, is in between, and some don't. Some can't do it.
Some are too dumb.
It's just the way they're built. Anyway.
So when we get a residential call, that call has to be placed by a phone. Anybody, you guys have Kathleen has a traditional lamp for your mom, right? Anybody else have one?
Yes, I do.
You're the only one then, right?
And it was hacked trying to get it back.
Yeah, recently too. You got rid of the VOIP and got that, and it was just, very hard. So she wants that line out in all cases when power is out, and that's how you do it, a traditional landline. Cell phone was difficult for her mom to use. So, those things were, real killers, for the elderly and for businesses. They're the ones that tend to have those traditional phones or areas that are poorly served by wireless. So how does that
places now?
Go ahead.
What percentage of 911 calls are landline calls? I mean, where are we with that?
No more than, very few areas have more than 10%. The numbers are skewed though, because multiple calls come in from a wireless, from an event on wireless phones. Accident on the highway, somebody reporting suspicious behavior, if you think about a major incident and how many people might pick up their wireless phones and call 911, where a landline, and it could happen in landline with something going on in the neighborhood or whatever, but medical emergency is one person picking it up. So you get many more calls, like 90% of the calls are coming from wireless devices. But that doesn't mean that's 90% of the incidents, if that makes sense.
Well, yeah, and I mean that tells me that there's very little incentive for the carriers to put money into landline infrastructure.
You are exactly right. And what happens? People steal the copper too. I have friends that can only get a landline, and their house is a mile back from 21 Glen, and that copper's been on the ground because they won't hang it, and then people just come and steal it. So there's just all sorts of issues about landlines. It's going away. It's more expensive infrastructure to maintain. People don't want to do it, but it exists. That system exists, and that system is routed in a traditional fashion too by telephone exchange offices. They're called central offices, all being connected together in a more traditional fiber in the ground or copper in the ground network. Versus the IP-based networks where it all becomes IP traffic. And the only IP traffic in most systems now is inside the 911 center. It's getting to them in traditional manner, by wireless, because wireless even, it's converted into, it's still delivered to the 911 center on 911 trunks, which are phone cables, basically. So, they're different wireless versus landline trunks, but it does its own thing with its own routing, but then it's trundled back to the 911 center in a traditional way, not IP.
So the towers are connected to Right.
Yep. The
To the
towers are
exchanges.
connected. They have a different routing functionality, but they're connected back to the main tandems and things. So anyway, I basically then what is the mapping of a 911 landline call? It's traditional. It's the house number and the street name. Of course, if there's a community and a unit number or whatever, that's all basically, it's interpolating the address by finding a point that matches or interpolating the address along a center line, just like we do with geocoding. So that is how a landline call plots. It's very dependable because, you know, you believe that if that is a house number for that structure, you know, that you're getting the right location. Landline call locations tend to be more accurate than overall than cellular call locations, but they're going out the window. So when our software sees RESD or BUSN, it interpolates, it looks for a match on a point, and if there's no match to the point, it interpolates the address along the center line. And it does use community so that it resolves duplications of, you know, main streets and pines and all that, highways, using that community code or that postal code. Okay. This is what, I'll share this, but this is a basic, you know, definition of how landline call routing works. When you call 911, your call is routed to a building called a central office. So it's based on your telephone exchange. I have a 274 number. That's a Cedar Hill telephone exchange. It goes to the central office in Cedar Hill for the Cedar Hill telephone, the 274 exchange. It uses my phone number to send my call to the correct tandem office. That's just the big router that the phone company uses, which is divided by regions. Based on the information stored in the tandem office, which is in your, you know, MSAG, ELT, all of those databases that we use, your call is routed to the correct emergency communications center. That's a PSAP. And then it just kind of goes on, you know, and then it doesn't even query the database to get your information, the alley, until that person, when that operator answers the call, 911, what is your location or what is your emergency, whatever they say, that they're in that just real snap, that's when that database dip goes, and it goes back to the database to find out what physical information, you know, location information is associated with that 10-digit number, and it brings that back to that 911 center. So it's very traditional, very database. You know, the routing is based on the database. It's not spatial, you know. So it all happens in seconds, like they said. Okay, this is the piece that's hardest to fit into the next generation system. Okay, sorry, I have all these, you know. Everybody's back at work finally, and they're all sending stuff. So, okay, so this is what a central office looks like. That's the Spring Hill, Kansas telephone CenturyLink central office. It's that little brick building. You see them a lot of places. You see them in small towns. A lot of times they're next to the phone company building in towns, but you see them out on the highways too. Little brick windowless buildings.
See them on the
sometimes
interstate.
they're not brick, sometimes they're metal. Yeah. They usually have a tower or something. This one, maybe they don't even have a tower. I'm wrong. That's just the building itself. You know, the phone company building.
So where's the one?
And it's just full of. Where's Cedar Hills?
Yeah.
Kathleen?
Yes.
Yeah.
Yes.
I've seen it. It's in Cedar Hill, but I don't remember where it is. It's next to the center. Okay, it's in the town of Cedar Hill.
Yeah, that
Yes,
little
it's in
that
town,
building in town.
up on High Street. Yeah, it's that little building that's kind of a metal, weird building. It doesn't have windows. It's bigger than this.
Yeah, it is.
Yeah. Mm-hmm. So you know you'll start seeing them once you know what they are.
The most
and this one just
interesting
happened
ones
when
of these I've seen is in Manhattan. It's 33 Thomas Street. It's a 550 foot tall phone switching building. It's incredible. It's like a brutalist.
Oh my God.
Nightmare, yeah. Look it up. 33 Thomas Street.
You know, that's very interesting.
I will look this one up.
If anybody has, you know, the inclination or desire, are those the same thing? Well, anyway, you should Google ghost buildings.
Okay, what is that?
Which aren't that they're buildings that may look normal to everybody, but they're really something entirely different. Is, you know, it's usually some kind of infrastructure.
Okay.
But like, it's more of an urban thing. But you know, yeah.
Yeah.
But like one of the things when I looked it up was like, oh yeah, like a lot of telephone stuff is housed in these ghost buildings. They look like a like what do you call it, a brownstone, you know?
Yeah.
But really, there's no
Interesting,
units
yeah.
inside it. It's all like equipment and shit and stuff. Yeah. Anyway, sorry.
This would be
There's a,
full of,
There's a Verizon switching building in Lower Manhattan too. That's like very, very, very prominent. It has no windows.
Right.
So,
Yeah.
so look that up. Yeah.
Anyway,
What's
we love
interesting?
Spring Hill, Kansas, probably.
what
Go ahead,
Curtis?
Curtis, yeah.
What's interesting is these
ahead.
offices like this right here. Starts off, you walk in the door, and there's just tons of wire and everything in the door, and you
Yeah.
hear clicking, all this stuff. But they've been converting to fiber optics and VoIP, and so sometimes these buildings like this, they actually play tennis or something or handball inside the building because there's just a little box over in the
Oh my
corner.
gosh.
Yeah.
The only one I've ever been in, Curtis, it was earlier, and it was I was with, a CenturyLink guy, no, just let me look in, and it wasn't this one, but it was wire everywhere. I'm like, oh my, like one of those old telephone offices, but that makes sense. This is from Google Street View, and this van happened to be parked in front of the building. I knew where it was in Spring Hill, and I was looking for him. Like, well, there's the CenturyLink van, must be there, and it was. So, yeah, interesting, very interesting. So yeah, the world is changing. Everything is changing, and this is all going to be going away. But we deal with it now. I mean, we deal with this traditional landline call routing now. Honestly, if we have a problem with a landline call not plotting correctly, it's because something about how they enter that address in the database is not matching the GIS. Maybe it doesn't have the street type. Maybe it's 2 words versus 1 word. It's just it's an MSAG error is what it comes down to. Those are the easiest to resolve. So, yeah, I want to see one of these that's been converted to fiber now. So we talked a little bit about wireless call routing. That if the system can't, in the time it has, if it can't resolve the location of that caller, it returns a phase 1 call. And the phase 1 call means, oh, here's where the tower is. That's going to help me. Well, the only time the tower location helps is if somebody's jumping off the tower, right, with their cell phone. It's not important except to know that, okay, the call probably originated within 15 miles of this location in this pie-shaped area. But what the system does then is it's usually set to auto rebid. It just keeps querying that position until it returns a phase 2 of WPH2. WPH2, 2 different things. It's the handset solution, which is a more accurate location. However, it's not like Uber. It's not like anything that you would use in real life. It's interpolated through the location interpolation used by the 911 network, which is not the same as just raw coordinates from your phones being sent across and it's good, because all these other things use all the other location devices that are available, all the Bluetooth. And I don't even know them all, but they're hotspots and all sorts of different things that they can use to better pinpoint your location. Think about it that you get pretty close to the building, wireless phase 2, but if you're using Rapid SOS, which is a layered program on top of phase 2, you get where you are in the building. It's basically, I usually get you in the building with phase 1, and phase 2 gets where you are. So it's just a lot more. It's a lot more granular. So basically, the wireless has its own routing system, but it all ties back into the same, call delivery system. And mapping is routing of that call is based on where, and I know we've gone over this many times, but it is based on the antenna of the tower can only be sent to one 911 center. So you have a tower sitting inside a city, and half of its traffic comes from the county, and those county and city have different 911 centers. It can only go to one of them. Then they have to determine location and send it to the correct 911 center by forward. And that's what changes with next generation 911. It's your location, not the tower location, that determines where the call is initially routed. we just had a call, Glenn, don't panic. They are finally fixing the PSAP boundaries in Delaware, Craig, and Ottawa to go back to county boundaries. And I was talking to Billy this morning because what if there's a call, right now there's a tower probably sitting in Monkey Island.
Right.
And probably it picks up traffic from a lot of Delaware County, but a lot of Ottawa County too, and talking about how to route that appropriately. So anyway.
I'm not panicking. No, that's a good
And
idea. You know, it's just timing. But anyway.
Yeah, you have to go back to the routing sheets and see where each direction, you know, where each cell
Right.
tower, you know, antenna is faced, you know, what direction it's facing and everything. The mapping of a 911 phase 1, phase 2 call, you can map to address of the tower. That's always an option. But what we would do is map to the coordinates of the tower instead of the address, because there's no real good way to make those addresses MSEC standard on those towers. Nobody does it. Half the time they append the direction. We'll say like 1234 Main Street hyphen Northeast sector, which is not a real street name. That's how they convey it. So we can map the raw coordinates, and they use a different symbol for phase 1 or phase 2. On a phase 2 call, mapping the coordinates shows you pretty much where that caller is, but it doesn't give you an address. So some systems interpolate an address by drawing a perpendicular line to the closest road, which is a horrible way to go about it in the rural areas of this country, because the closest road may have absolutely zero access to that property. If you think about it, you know, you get a call out in the middle of the, you know, I don't know, a mile off the road, and you just say, you know, they've taken a forest road down or a Jeep trail, and they're hiking, and they're a mile off the road, and they call 911. The closest road may be just across the ridge, you know, a quarter mile away that they have no access to. So anyway, but does that make sense? You know, they pinpoint the location, and then they interpolate the address by looking at the GIS and having the software just make a geocoding decision based on the closest road. So, anybody have any questions on that? So if they call you when they say it mapped me here, you're like, was it a wireless call or a landline call? Because a wireless call, you want to look at those raw coordinates in association with your mapping and make that determination yourself. They want that address though, so they can enter something in their CAD, so they can create the incident. And it just really depends on the CAD system and how it works. You know, CAD is not mapping, guys. CAD is records management. You know, it is making dispatch decisions based on all the information you can possibly have that's stored about a location, about a resident, about, you know, a phone number. That's what CAD is. And many of them use mapping to implement CAD or alongside and, you know, integrated with CAD. But as itself, it's not mapping. And have a mapping element. Okay, so this is just a real quick, you know, triangulation timing thing, you know. Triangulation is really called the network solution because it's using the cell phone network to determine location by pinging off that phone and determining distances and speeds and things like that. It's math. The problem is, if you're out in the rural America, you're going to have access to 3 towers all the time?
Nope.
The answer is no. No, you won't. And because you don't, if you're trying to determine location from 2 towers, what happens, you know, for those of you who are, you know, mathematicians, not me, you understand that you're not going to have the, you know, you're not going to be able to make the same kind of intersecting circle decisions that they're using right here with 2. So, you know, you don't get that single point. If you have 2, you get 2 potential points. So it is much more precise in cities, in areas where there's line of sight, you know, between towers, not in a lot of rural, you know, rugged America.
You can get.
You all know that you. Go ahead.
Sometimes you can get a signal across 2 different antennas on the tower that are angled at different directions. And you get a weaker
think about that.
One,
yeah.
And a primary signal on the other one, and then the calculation will calculate as close as they can to that location. So.
Right. Because it does try when you don't have one tower, when you don't have the 3 or more towers. So yeah, so that's a good point. I haven't delved into this as deeply as I could have had I just, specialized in, I'm going to specialize in 911 call location. With us, it's always just a little ancillary thing we need to understand to be able to do what we specialize in better. So Keith could go talk about this until you wanted to go out and put your head in the pond. Sorry, Brian. Don't want to. He knows a lot about it. Let's say radio stuff and stuff. He knows a lot about.
Well, he worked in that industry before.
He did
in that ancient
for a long time. Yeah, he worked in GPS and all of that. We were working in 911 mapping, addressing back when the first
Before
wireless calls were
GPS
actually,
was
911 calls were routed.
Or we could even have GPS accuracy.
VoIP is really interesting because a VoIP call it seems like it's a landline call. It comes in like a landline call would. You pick up what looks to be a landline phone in most cases, and you place your call. But it's an IP-based system that is connected to the 911 network. So I have used to be Charter Spectrum phones, okay, and they're IP-based. So when I dialed 911 from my Spectrum phone, it doesn't go to the 911 system directly. It goes to the Spectrum call routing center. Each of the VoIP places have a call routing center. Those calls are plotted and they maintain their own PSAT maps. And then they have connectivity to the 911 system, and then they forward that call from their routing center to the correct 911 center. If they can't, for some reason, that call will not, they don't know where it's coming from, or they don't have whatever, they answer the call. They'll answer that call, 911, and then they try to determine where you are by talking to you and then send you to the right 911 center. So realize that it's based on, in most cases, the address that you provide. So when I set up those phones, I had to tell them my address was 703, 23 Wedgwood Drive, etc. And then they, enter that in. But if I moved, took my phones with me, I'd have to change that address. So you see that happen, where people that are deployed overseas will call 911 from overseas, and they'll get their, base 911 center or whatever. So it's incumbent upon the owner of those phones, the user of that account, to change that address when needed. However, we've noticed in our work that a lot of VoIP calls now include coordinates too. So if they include coordinates, that's usually a much better way of locating that, because it's basically not going to change when an address changes. I mean, yeah, the whole system moves, it does, but basically we can map either way. So you can see it's going to map like a landline or wireless call, depending on if it's using the coordinate or the address. Now, what's interesting, if the call center answers the call, they're not going to be getting the data of where you were calling from and all that. They've got to then make a manual routing of that, forward of that call back to the appropriate 911 center. So it is a much more prevalent, there are more VoIP phones than landline phones for sure. And more of these private branch exchanges, these old-fashioned exchanges, are now VoIP exchanges. So there's a lot going on in the background. But for you guys to know that it was a VoIP call, it's real, like Julie called with this one. It's like they couldn't figure out why the caller or the client couldn't figure out why it went to this call center. When we think call center, we don't think 911 call center or VoIP call center. We think it's some warranty center, or some phone bank trying to sell us junk. We don't think about it.
It's in India. It's somewhere else.
Yes, we're not thinking it's 911 based. It's Verizon's or Vonage's or Spectrum's 911 center, because they have to take on that responsibility of being able to get their calls back into the 911 system. You guys all get these emails. I get them from MSAG, people that work for these call centers that need MSAG changes, because their phone numbers have to be MSAG compliant. Their addresses associated with phone numbers have to be MSAG compliant. And I get them from Southern Missouri all the time, from like New Madrid and places like that, where they have a call, they have a client, and it's a VoIP client that is not, and it might be a Verizon VoIP client or whatever, but they need an MSAG correction for that. We get those way more often than we get things from the actual 911 coordinators wanting an MSAG update. Okay, I'm past my time, but this is my last slide. So text, I talked a little bit about text. I'm only now seeing text coming. It used to be the text would come in, but it wouldn't come in on a 911 trunk. Now we're starting to see that. Okay, so if you're in a 911 center and you get a phone call, if it's a 911 phone call, it rings differently than if it is an administrative call. Somebody just calling the sheriff's office to ask for something or, whatever, it's a different kind of ring. That ring means priority if it's 911. A text message coming in needs to have that priority if they texted 911, obviously. But it wouldn't have that priority if it's not coming in on the 911 system itself. It's just coming in like a regular text message. That's the whole thing they have to work out. And that's why if when you text 911, really text 911 because you legitimately cannot talk. That's when you text 911. You're in danger, you can't talk because of a medical situation or whatever, use your voice if you can. I tell my kids that all the time, not this kid, but my other one. Just call. You can retone with the voice, but it's just what people do now. They want to text and not talk, but it's not ready yet from an emergency perspective to get really good results for that. So, basically the pieces that I put together, but it's all coming down, the whole reason behind this is that when you get a problem reported to you and it's because something didn't map or plot correctly, you have to know, was it your CAD that created the error? Was it call mapping? CallWorks is not CAD, everybody. It's call mapping. CallWorks is a call answering system. It's a call taking system that has mapping. So it plots the call location, but it's not doing all that CAD functionality of recommending responders and community and all that stuff. Okay, or bringing up, past, medical conditions based on past calls from that location. It's not database. So you have to know, like, where was the error generated and what kind of call was it? Get as much information as possible. And I'd be happy to run through these as I have with Julie and I think with Ryan. I've run through these with some of you, as you've come back to me about them. And I think by doing that, you learn a little bit more about how what we do fits into the whole system. Because we're having to anticipate what that call mapping or that CAD mapping is trying to do. So, has this cleared anything up? Because I need to know where to go next, not now, but then, if we need to drill deeper, I don't want to drill into all of these things. I want to drill into one of them at a time. So think about that.
One of the things that I don't see here is there's not a lot of information about where you're sourcing your information. When they come in and they complain about not getting an IP, getting IP calls that I don't have anything to associate it with, is there something wrong with my system? Then what sources of information does a client have that can tell you what's happening?
Okay, so the client itself.
Okay. It was pretty easy to do because it had a screen, that you could grab and tell what's not there and what's is there. And for that matter, a phase 2 call is the same way. But when you start talking about VoIP and text, there's so many different types of VoIP and text approaches now.
Yeah.
That
we're constantly adding more classes of service because of that. Yeah. So,
for instance, you can buy VoIP phones now that have a antenna or a module modem in it that gets a contract with multiple carriers, and then basically they're
I've seen those.
They're only trying to get the data portion of the carrier so that they can VoIP it out to the internet, and then they intercept your call through some service that they have, and that's usually where you're going to get an operator that's going to ask your question, where are you? or, that kind of thing.
Right.
But there's also some things that you put in as hard coded so that when you're home, your address is in it. Well, that doesn't help you when you're
Right.
roaming around.
No,
So
it doesn't help when you're
some of
roaming.
these
When you've got that
phones are
phone
hard to know
out.
that
Yeah.
you're roaming. So there's a lot to that.
Those are really good questions. Yeah. Great questions, and we still have a couple years where we're going to kind of almost not have to worry about those things because of the way that next generation is going to try to pull all these things together. With me, it comes down to experience, what I've experienced before, and then knowing how to triage. And I think that's what it really comes down to, Curtis, is being able to triage this and to give the client, maybe to give us and to give the clients a way of, what we need before they report it back to us.
Right.
And, so that basically probably is something we need to develop. You've reported this issue, and then it's like, we need this whole slew of stuff. We need to know. Anyway, you're just giving me more to think about right now, which is fine because I don't want to leave people hanging. I want to give you real information. And there's, like you said, I am so overwhelmed with the amount of just the technology with, blending the wireless and VoIP stuff, like you said, the way people overcome these things or get around dead areas, making wireless calls by, not just, when I say wireless calls, not using the network, but using your broadband at home with your wireless to make phone calls. There's the IP address location or whatever.
But,
I think that I'd like to.
Some of them switch over to landline when you dial 911. The phone just transfers it over to it.
In the past, we worried about ring downs, Curtis, where somebody had a phone number in their business that also rang down to their home.
Yeah.
And so we didn't know if it was coming from their business or their home. That was an old problem.
Yeah, exactly.
And it was really not a way that they could. You remember those? And not all carriers provide, but some did. Anyway, kind of like a party line, but not really. So, well, I'd like to let everybody get back to work. Curtis, I'm going to follow up just a little bit. I think we need to put together something so that we can. There's a point where we do not need to triage this. We can't. We are not. We're going to have to refer them back to whoever. But I'd like to be able to say, you need to contact this, oh, it was a Vonage call. You need to contact them, and find out what's going on. And I like to stay abreast of these things just because it keeps somebody up and knowing, where do we go with this? How do we drill down into this error that Marshall County is reporting, Because it was the last one we had was like a 12, I don't remember how many phone numbers they had, and none of them were mapping correctly. It was a school or something. And we're like, you're going to have to get in there and enter that physical. This was the call center that called us. They were just, was it Pine or one of those that we deal with, in these small areas of Oklahoma? Pioneer. It was Pioneer. It was Cotton County.
Yeah.
And they were just starting to sell this, and she didn't know in her system, and this was the phone company, the small phone company, Pioneer, smaller, that they had to enter those physical addresses for all those different phone numbers associated with that, with that main number. So, yeah. So,
Yeah.
Okay, well, guys, go ahead.
Can Susan and Ryan hang on for 90 seconds?
Yes, sir.
Sure, I can. Yes, I can.
Okay, thanks.
Well, thank you all. Thanks for the good questions, and we